Hello, everyone. Welcome back, everybody. Welcome to the class. Good evening. I'm good. Thank you for asking. Hello. How are you all? Sir, why are you not taking YT guidance session? ये क्या होता है? YT guidance session क्या होता है? YT का full form पता है मुझे, but what is YouTube guidance session? Who took the YouTube guidance session? You guys get a personalized guidance session, but you guys want separate guidance session on YouTube. What? The call one, sir, where children call you. Acha. Okay. You mean the counseling one? Okay. I know exactly. So Shimon sir set a record by leaving us 63 minutes early. Good for you. Good for all of you. What else do you want? हाँ सब कुछ सेट है लाइफ में और क्या चाहिए? Happy Lakshmi Puja. As much as I remember last time, Lakshmi Puja used to happen on the day of Diwali, and today is not Diwali. Who's celebrating? Who's worshipping Lakshmi today? Huh? Though you can actually worship Goddess Lakshmi every day, but I would recommend worshipping Goddess Saraswati more in this age. That will actually bring you more wisdom. No? In some parallel universe, we have like, okay, in Bengali culture, so yeah, Valmiki Jayanti, something Valmiki Puja is there. No, today there are no machineries work. They are given rest. They are being worshipped. Okay. Sir, you set a record of 90 minutes. I'll set a record of 120 minutes today. Let's just end the class. What do you say? है ना? Just go. Done. But I'll not reteach the session which is supposed to happen today. चलेगा? है ना? Sir, what's meant by Janta? Seriously. Janta means public. Okay. So everybody's ready. We have two class teachers, Anshul sir and Anil Tiwari sir. Say hello to your class teachers quickly, everyone. Quickly say hello to your class teachers, the awesome class teachers of physics. They make our life so easy. They make us conduct this session so smoothly. Okay. Somebody's asking, sir, how do we know where do we use linear mass density and area mass density? We get to know it when the question comes. Okay. Okay. You actually don't need to think more about these different type of densities. You can always work with the density always. The normal density that you know, mass upon volume, you can always work with that. Sir, we have theory more or questions more today. I think today we only have like a little bit of theory and it is only continuation of Bernoulli's theorem. As I told you guys last time also that we will be continuing with the Bernoulli's theorem and awesome applications of Bernoulli's theorem. Today you are going to learn how the aeroplanes actually fly. What is the fundamental behind the aeroplanes fly? What is the fundamental behind the deodorants bottle, those spray bottles? You will get to know how in Bollywood movies, those village houses, their shades just go off. Why that happens, we'll be speaking about all that today. Those things happen because of Bernoulli's theorem. Okay, so everyone is ready? Yes, so it's not like super movies of Rohit Shetty. We'll rather look at the boring physics behind it today. Okay. Archana says, sir, because of you, now I have habit of calling my friends and family as Janta while making announcements. They asked from where I learned this from. Later, while seeing your Telegram messages, and I replied, I realized I got it from you. It's a good that you have got this word in your lingo almost 2 years earlier. Usually, these words we learn when we get into engineering colleges, but then the side effects are that you're learning from an engineer, so definitely some of the side effects will rub on. Right? So, everyone, are we all ready? Shall we start? Everyone is ready? Awesome, good. So, let's have a +1 in the chat box if everybody's ready. Sure, everyone, let's go and do a quick recap of what we did last time, switching off the chat so that we focus. Okay. That's good. Okay, so last time we spoke about mostly two more important topics. First one was basically we spoke about what we study and how we study the fluids which are under motion. So fluid mechanics, fluid dynamics is what we started, and majorly two topics we covered last time. One is called equation of continuity. The second one is called as the Bernoulli's theorem or Bernoulli's equation. So we understood that when we are speaking about fluid dynamics, as of now we are only speaking about the ideal fluid, and an ideal fluid will always perform streamline or laminar flow. And streamlines are basically the lines which we draw in order to represent the flow of a liquid, and they will never intersect with each other. Their density means how close the lines are. That will actually tell us that how fast the liquid is traveling. Okay, and they will never intersect with each other because the streamlines are giving you the direction of flow of the particles. And we can say that when fluid particles does not flow in the form of layers during the fluid flow, intermixing happens, and the flow can be said to be turbulent in that case. So we'll speak a little more about turbulent flow maybe in the upcoming sessions when we speak about something called as Reynolds number. Okay, then we spoke about something called as equation of continuity, which was basically telling us that the volume flow rate, amount of volume entering and exiting per unit time through a tube, is always going to remain a constant when we are speaking about, say, an ideal fluid, incompressible fluid. Its density is not going to change. It's not going to show any kind of viscous effect. So A1 V1 will remain equal to A2 V2. After that, we did the derivation of Bernoulli's equation. Bernoulli's equation is basically law of conservation of energy during the flow of the liquid. We understood that pressure plus h rho g plus half rho v square will always remain a constant. Can be applied at two different points during the flow of the liquid. Okay, rho gh is basically potential energy per unit volume. Half rho v square is the kinetic energy per unit volume. The summation of the three terms will always remain a constant. It may so happen that when the height is not changing, rho gh value may remain unchanged, and accordingly so on and so forth. We'll study about that. So these are the small topics that we covered last time, and as always, the mechanics does not contain much of theory so far, and more of problem solving happens. That's why, based upon what we did last time, let's see if you can answer this question. These are two questions coming up for all of you guys. Question number 1. It says that if a liquid enters a pipe of diameter 2 with a velocity v, what will be its velocity at the exit if the diameter reduces to 0.5 d? Or that means if the diameter becomes half, what will be the effect on the velocity of the liquid? Giving you people 90 seconds and the time starts in 3, 2, and 1. Come on guys, equation of continuity, straightforward application. Let's see if you can do this. Very easy one. Today's questions are going to be relatively lengthier, more challenging one because of the expressions being lengthy. Okay. Thirty seconds remaining. Should be easily done by everyone here. This is the simplest of the question that you can expect from equation of continuity. Okay, last 15 seconds now. and the time is up. No. Simple it was. A1 V1 will be equal to A2 V2. So definitely if the diameter is decreasing, area is decreasing, velocity has to increase. So earlier the area is pi r square. If diameter is becoming half, definitely the radius is also becoming half, right everyone? So I can say that earlier the area was pi r square, velocity was v, and now the area becomes pi r by 2 square and velocity becomes v dash. Pi gets cancelled. We have v into r square equal to v dash, r square by 4. R square gets cancelled. V dash comes out to be 4 times v. Okay, we can say that if d becomes d by 2, then r becomes r by 2. Simple as that. Okay, so correct answer is option A. Okay, now second one is going to be the application of Bernoulli's theorem. The water is coming out from a tap. Point 1 is where the water is leaving, and 5 meters below is point number 2, where we can consider height is 0. So at point number 1, area of cross section of the stream, which is flowing down, is 1 centimeter square. Velocity at that point is 10 meters per second. Question is asking us that when it has fallen, the liquid stream has fallen by a height of 5 meters, what will be the now area of cross section, and also what will be the value of the velocity of the stream? Okay, that's good. Giving you complete 2 minutes, all of you try to apply Bernoulli's theorem, P plus rho gh plus half rho v square between the 2 points. Okay, giving you 20 seconds or 2 minutes, and the time starts in 3, 2, and 1. Come on. I'm smiling, and I will tell you why am I smiling. But first, you guys attempt this question. "45 seconds remaining. Response is very low for the question so far. Come on, everyone. At 1 and 2, the pressure value is going to be atmospheric pressure. Let me make it easier for you to think. "10 seconds more. And the time is up. Okay, so why was I smiling? Is because this can be answered without even lifting the pen. This question can be answered without even lifting the pen. Can anyone tell me how? How will I get to the correct answer? Tell me, guys, can I say that definitely V2 is greater than V1? Can I say this definitely? V2 is going to be greater than V1? Correct? Right, everyone? Even without trying A1 V1 equal to A2 V2. Can I definitely say that A2 will be less than A1? Surely area A2 will be less than A1, and A1 value is 1 centimeter square. This value is 1.41. 1.41, this is 1.73. Only value which is less than 1 is this. And the other method was, we know that A1 V1 is going to be 1 into 10. That means this value should come out to be 10. So A2 V2 for option A is the only option where I get 10 root 2 multiplied by 1 by root 2 as 10. That's the other method. If you did the second method also, that is also acceptable. Smart work. But if you went with the actual approach, then you deserve a medal. Okay. Now, as the people who went for the medal, let's just see how it was supposed to be done. Yeah. So A1 V1 is equal to A2 V2 for sure, and between 2 and 1, I'm considering this point to be at h equal to 0. So stopping the chat here. Yeah, no problem, worry. So P naught is the pressure at 2. The velocity over here will become V2. So half rho V2 square, rho gh is going to be 0 because that is h equal to 0. At 1, pressure is again atmospheric pressure, velocity half rho V1 square, the kinetic energy per unit volume, and rho gh, rho gets cancelled, P naught already got cancelled. So this is the equation where we landed last time also. So V2 comes out to be 100, or you can say V1 square plus 2gh, V1 is 10, square that value, 2 into g into h. This comes out to be 200, so velocity is 10 root 2. Simplify that by A1 V1 equal to V2, the value will come out to be 1 by V2. So this was still doable in 2 minutes, by the way. Okay, this was still doable. Not that the time was not enough, it was sufficient enough time to get this. Okay, very good, Kaustav. Chalo, everyone, so let's start today's session. Okay, and the medal for all of you so far. Okay, yes, that's what you get. Chalo, everybody, switching off the chat. And what are we going to learn today are basically the applications of Bernoulli's equation or Bernoulli's theorem. Okay, the first one is called as velocity of efflux, and the second part of it will be called as Venturi meter. When that comes, I'll tell you what exactly Venturi meter is, and we'll see more applications of Bernoulli's theorem after that. So let's first speak about the velocity of efflux. That's a particular application of Bernoulli's theorem only. So this was studied by an Italian scientist. His name was Evangelista Torricelli, awesome name. And in a very short span of his life, for only 39 years, he could still come up with this explanation of the velocity with which your liquid is going to come out when you create a hole in the container. So say, guys, if we have a container in which there is some liquid which is filled, okay, and what you do, say you keep it open to the atmosphere and you create a hole somewhere here from which the water starts to fall out. Okay, so you create a hole of small area A, and velocity v is the velocity, okay, with which the liquid starts to come out. Have you ever seen that, or can you guys visualize this? Just imagine the water tanks which are on the top of your building, top of your house. If you puncture it by a small hole, the water from the hole will definitely come out very fast. Okay, the water will come out very fast, but the overall water level in the container, it will not go down very fast. Do you agree on this, everyone? when we speak about this velocity, can I say this velocity is almost equal to 0? Because this area is very high, we are saying that capital A is very, very large in comparison to small a, and capital V is almost equal to 0. And let's call this velocity as u, so that we don't get confused between u and v here. So what Torricelli's equation did, he found the value of this velocity with which the liquid will start coming out using the Bernoulli's theorem. Okay, yeah. So let's see what is this studied as. So first of all, this hole is created at a depth h, or water level above the hole is h. Okay, so maybe the water is actually filled to a height capital H, but remember the expression will come in terms of small h, and small h is not the height to which the water is filled; it's rather water filled above the hole, the level of water filled above the hole. Okay, so what we are going to do, we are going to pick 2 points. One point will be on the layer which is of the container, and one point will be considered just at the hole which you have created, and you will apply Bernoulli's theorem in these 2 points. So have a look at this, guys. So point 1 and point 2 are being chosen. Both of these points are exposed to the atmosphere, so the pressure which is acting on them is atmospheric pressure. It is the hole which is created at a height, or rather at a depth h. Okay, and below it, the remaining height is h minus h. Capital H is to which the liquid has been filled in the container. And if you think of it, I've told you that the velocity with which the container level is coming down is almost 0. Means it is a very slow dropping level comparative to the speed with which your liquid is going to come out from this point. Okay, everyone? Cool, everyone? Is the situation so far clear as far as the equation of continuity is clear or concerned? We are interested in finding this velocity. Okay, so what we are going to do, see, everyone, what am I doing now? Okay, so at 1, the pressure is P1. And as I'm considering this level to be h equal to 0, this height is going to be h. So h rho g, this h1 is going to be h. Okay, half rho v1 square, v1 ka value is almost equal to 0, h1 is almost equal to h, or not almost, it is equal to h, and h2 is going to be 0 because that is the level that we have considered, and half rho v2 square, v2 is basically v, which we are interested in finding. Okay, so you can see that p1 and p2 are basically p atmosphere, so they are also going to get cancelled. So have a look, guys. P atmosphere gets cancelled, h1 becomes h, so rho gh, the velocity of the level dropping is almost 0. Okay, so that is 0 written here. Rho g, the height is 0 of this level. Okay, and half rho v square, we are interested in this velocity. So what are the terms which you will be left here with? You are left with rho gh on the left hand side, and you are left with half rho v square on the right hand side. These are the 2 terms that you are going to equate now. When we equate, you can see that further rho gets cancelled, and v square comes out to be 2gh, and simply the velocity with which the liquid is coming out, the velocity of efflux means velocity of the outflow of the liquid, comes out to be under root 2gh. Easy to remember, as it is simply the kind of formula that we know from equation of motion. But please do not try to correlate it with that. We have got this expression as under root of 2gh, but remember this h is the depth of the hole from the top of the, or you can say the free surface. From the free surface, you are looking at the location of the hole. That is basically your height, or you can say the level of the hole. Now, let me just give you a brief recap of what projectile motion used to be, because the liquid is coming out from this hole, and it is coming out with a velocity say v, and it is going to fall for a height of h minus h. Okay, and it is going to perform a parabolic motion, projectile motion, and it is going to say cover a distance x. Okay, everyone, so this is y, the height by which your liquid is going to come out. So when we used to calculate the time to go from point A to point B, that time used to be under root of 2y by g. This is the time which is taken by your liquid drop to go from A to B. Okay, guys, which velocity component during projectile motion remains constant? Which of the component of the velocities remain constant? X component. So can I say that throughout this motion, the x component of velocity will remain the same? So if I want to find out x, can I say that is going to be v into t only? Correct, everyone? And what is the value of v? V value we just now found. Above this level we have h, so under root of 2gh is the value of v, and the value of t is 2, y value is capital H minus h divided by g in under root. So you're going to put these 2 in the expression here, and you'll be calculating the distance which is traveled by the stream and where it is hitting the ground. So that comes out to be 2gh in under root into 2 capital H minus h by g in under root. Okay, so you can see that g is getting cancelled, 2 and 2 will be multiplied together, so 2 will come out, and you will have under root of h into h minus h. Do I need to memorize this? I do not recommend memorizing this, rather remembering how we used to simplify this. Okay, everyone remembers? Is that clear? No circular motion. Yeah, projectile motion. Circular motion kahan se dikhai de raha hai? Okay, everyone? And that is the expression that we have here, under root of 2gh, under root of 2h minus h by g, and finally 2 times h into h minus h. Remember, h is the location of the hole from the top of the layer of the liquid. Okay, and also if you differentiate this term, okay, so how do we find out the maxima? I don't know whether you people remember this or not. I taught you people this. To find out the maxima or minima, you just differentiate that dy by dx should be equal to 0. So dr by dh, for which value of location of the hole, you will be getting the value of r maximum. So dr by dh को differentiate करके जब 0 से equate करेंगे, okay, so the value of h will come out to be h by 2. So that means if you create the hole at the midpoint here, then the range is going to be maximum. Okay, and you can find that also. That value is going to be h ka value if you put as h by 2. Okay, so this is going to be capital H by 2, capital H by 2, so h square by 4. So that value will come out to be the value R max. R max value is going to be 2 h by 2 into h by 2 in under root. So 2 into h by 2 is going to go to a distance that is equal to the height to which the liquid is filled. Okay. There will be no time for the liquid to travel if you create the hole at the bottom. The liquid will come out and hit the ground. That's why the whole location for maximum range comes out to be the midpoint of capital H. Okay. Are we all clear with this? सबको समझ में आ गया है? Everyone understands? Great, nice. Okay. बोलो. Prithvi Teja. Slide number 15. Slide number 15. Here we go. So does the size of the hole matter? Actually, it matters, but we are considering the hole size is comparatively very small in comparison to the entire diameter or entire area of cross section of the container. So in comparison, the hole is very small. Okay. So for maximum, the velocity maximum, where will we put hole? Obviously at the bottom. For the velocity to be maximum, we will create the hole at the bottom. What DA? Achman Shukla, I'm not getting it out. at bottommost point. Okay, yeah, could be calculus wala D. Uska kya? What do you want in that? At bottom, the range will become 0. Yes. Size of the hole is not dA. Size of the hole is small a. Ashman. Size of the hole is a, small a, and this is capital A. Capital A is much larger in comparison to small a. This is the condition. Okay. Okay. The area of the hole is smaller comparison to the area of the orifice of the container, or you can say the area of cross section of the container. Means, say this is basically the bottle whose diameter is going to be 4 centimeter. My bottle has the face diameter as 4 centimeters, so maybe radius is 2 centimeter. If I create a hole here, which is of the order of say millimeters or micrometers, okay, if I create a hole here, definitely that hole will be much smaller in comparison to this hole. Getting my point? So this is the condition that we are mentioning here. Okay. Okay. Sir, suppose if more hole is below A, will the velocity of B will be affected? Velocity of B. Yes, Rajkumar. नीचे भी और एक और होल आ जाएगा, उसकी वेलोसिटी दूसरी होगी, सेम रहेगी. Exactly. Okay. Okay. Can we compare like making a hole with a safety pin on a 20-liter tank? Yes, you can. Just be prepared. That day you may not get dinner at home. Sir, what if the velocity with which liquid is coming out is significant? In that case, we will actually look at that in some time in the form of questions also. When this condition is not true, then you will not be making this value as 0. That's it. In the equation of Bernoulli's theorem, this value will not be taken as 0. So we will look at those cases also. Don't worry. But that will be studied in the case of say venturi meter. Okay. What will happen if you put the hole at the bottom? Liquid will still come out, but with a faster velocity. Okay. If we create a hole here, the velocity is going to be under root of 2gh. That's it. V maximum. Okay. Yes, absolutely, Pradivya. That is something that we know from the equation of continuity already. If the area is small, then the velocity is more. Okay. Which formula do we remember from here? Formula number 1, formula number 2, or rather formula number 2. Okay. So is this case for ideal liquids only? Kind of. Yes. At the bottom, pressure is maximum, velocity is less. Who said so? Who told you so? At both the points, the external pressure is the same pressure, and that is the atmospheric pressure. Okay. Are we here? Let's have a look at some examples, guys. We'll be able to understand the application much better. अरे मेरे भाई, ये तो हटा ही देना चाहिए मुझे. ये तो लिखना ही नहीं चाहिए. लो, तुम्हें लाइफ में लगता है सिर्फ dy by dx ही हो सकता है, dx by dy नहीं हो सकता, और vice versa. So I'm not getting into that debate with all of you. When you will learn this in mathematics next year, you will understand this much better. Okay. आवाज आ रही है मेरी? ये कंटेनर है. तुम बोल रहे हो वाटर में उस कंटेनर में पाइप यहाँ क्यों लगाते हैं? यहाँ लगाऊंगा तो क्या पानी आएगा बाहर? मिड में लगाएंगे तो जब नीचे चला जाएगा लेवल, उसके बाद पानी आएगा बाहर. Okay. Thank you. Okay. Okay, everyone. So let's have a look at some examples so that we get a better understanding of this thing. So question says that how fast will the water flow out of the tank if the storage tank is open to the atmosphere at sea level? At sea level बोलने का मतलब ये है that the atmospheric pressure is 1 atmosphere or 1 into 10 to the power 5 Newton per meter square. So simply the value of h is given and we can directly find this out, and I think I should not be solving it. I should be making this question to be done by all of you people. Okay, so start solving, everyone. I'm going to give you guys only 15 seconds for this. And setting up the quiz for all of you. Giving you 30 seconds. Time starts in 3, 2, and 1. Find out the velocity of efflux when the hole is created at the bottommost point or bottommost layer. Parallel to that. Okay. Come on, everyone. Last 5 seconds. Chalo, very nice. Correct answer is under root 2gh. That's it. So velocity of efflux is under root of 2gh. This is 2 into 10 into 20. That is 20 to 20. That means 20 meters per second is the velocity of efflux. Okay. Easy one. Okay. The next one. This question is from JEE Main 2019. It says that water flows into a large tank with a flat bottom at a rate of 10 to the power minus 4 meter cube per second. That means volume per second. Volume per second is given to you as 10 to the power minus 4 meter cube per second, or volume per unit time is what I should say. This is called volume flow rate, or A into V. Okay. So water is also leaking out of a hole of area 1 centimeter square at its bottom. If the height of the water in the tank remains constant, then this height, which you will be able to maintain, has to be how much? Okay, everyone, let's have a look at the diagram first. So this is how the situation is. You are making sure that the amount of influx or volume per unit time which is coming in has to be equal to volume per unit time which is going out. If volume coming in becomes more than the volume going out, then the water level will rise from common sense. If I'm adding more water than I'm removing, then definitely water level will rise. And if water is moving out faster, more volume is coming out per unit time than the one that I'm adding, then definitely the water level will go down. I want to maintain a constant height. That height is what the question is asking. So we can say that if the intake volume per unit time is 10 to the power minus 3, the outgoing volume is going to be A into U. So the area of this hole is given to me, and velocity I already know is going to be under root of 2gh. So I can say that the incoming volume is 10 to the power minus 4 meter cube per second. The area of the hole is 1 centimeter square, which I can say is 10 to the power minus 4 meter square, and under root of 2 into 10 into h. We have written that. This cancels. So we can say that h is going to be 1 by 20, then only this value will be 1. So 1 by 20 meters is going to be 0.05 centimeters, or we can say, 0.05 meters or 5 centimeters. That's our answer. Is it understood, everyone? Everyone gets it? Gets the logic? Okay, great, nice. Well done. So get ready for quiz question. Question coming for all of you. Yeah. So question from the quizzes. This one says that water with density 1000 kg per meter cube and kerosene with density 800 kg per meter cube, they are filled in the two identical cylindrical vessels. Both vessels have small holes at their bottom. So the speed of the water and kerosene coming out of their holes are V1 and V2 respectively. So what do you think? You can comment on the velocity of water and kerosene coming out. Identical container, identical location of the hole, identical level of water also, and kerosene. So giving you guys 60 seconds to solve this, and your time starts in 3, 2, and 1. Okay, everyone, and the time is up. Let's see. Velocity of efflux, is it dependent upon the density of the liquid? Is the velocity of efflux dependent upon the density of the liquid? It is not. It is under root of 2gh. Okay, so in that case, the answer to this is going to be the same, V1 equal to V2, and that is under root 2gh. Okay, cool, nice. So switching off once again so that we focus on the screen. So water is filled in a container up to a height of 3 meters. A small hole of area A is punched in the wall of the container at a height 52.5 centimeters from the bottom. So the cross section area of the container is capital A. If small a by capital A is given to me as 0.1, then the velocity with which the liquid is coming out, if that is V, find the value of V square. What will be the value of V square if we create a hole at this height 52.5? You have to find out V square value, how much that is going to be. Okay, giving you people complete 2 minutes. You can think of 0.1 and 0.2. This time, small a by capital A value is given, and it is not given to you as negligible area, small a. So you can think of applying Bernoulli's also. Giving you 2 minutes, and the time starts in 3, 2, and 1. Okay, 30 seconds more, everybody. Though I've given you a big hint in the diagram already. Without that hint, if we approach the question, then the question is actually lengthy. And the time is up. Let's see. Okay. Okay. So first of all, guys, if I would not give you this, then you will have to write capital A into V equal to small a into small v. So we can say that small a by capital A will be equal to capital V by small v, and that value is given to me as 0.1. So capital V is equal to 0.1 small v, or capital V is equal to V by 10. Ideally, I should be going by this approach and then applying Bernoulli's theorem between 0.1 and 2. I should be writing P naught plus this value I can write as h equal to 0. Excuse me, and h rho g will be 0, half rho, sorry, I'm writing it for 1. So for 1, the energy will be h into rho into g, that is 3 minus 0.525. This is in centimeters, okay? So h into rho into g plus half rho capital V square equal to P naught, we are writing it at 2, plus 0 h rho g and half rho small v square. So this capital V, you will be placing it here, P naught you will be cancelling, rho you will be cancelling, and then you will be coming up with an equation that is V square equal to U square minus 2gh sort of equation. Means if you will go by this is how it is going to turn out to be. But then what did I do? I assume that this velocity is almost going to be equal to 0. I've assumed that. Okay. If you will not, if you will actually go by this approach, you will still get the answer, but the answer is going to take a little more efforts because you will have to write it as V by 10. Okay. So 3 minus 5.25 value is 2.475. Okay. So if you want, you can try that approach. Okay. As a homework, definitely you guys can continue from here and find out the value of small v. Okay. Is that clear to all of you? So see how easy I have made it. The options are not that close actually. They are enough spaced. So you can see that if I consider this velocity to be 0, then my answer is directly 2gh only. So you can say 2 into 10 into 2.475. This value is nearly equal. If I take this value as 2.5, then my answer is exact 50. Getting everyone? Is it clear to all of you? Can we use the formula directly of efflux? If you would in this question, you will not be getting the wrong answer. You'll be getting the right answer actually. You can directly use under 2gh in this one. But I've still given you the approach also. How should you be approaching? Some people ask me, sir, what if this is not equal to 0? Then what will we do? This is what you will be doing. You'll be putting v ka value as v by 10 and simplifying it. Okay? Okay. No problem. Okay. Awesome. So answer comes out to be option A here. That is close to 15 meters square per second square. Sure. Okay. Sir, in which cases to use Bernoulli? Wherever the fluid is going to flow. Whenever the fluid starts to flow, Bernoulli's equation becomes applicable. And here the fluid is flowing. Okay. Sir, I got C when I used G as 9.8. There is no way you will get the answer as 48 meters square per second square. Okay, Gauri Shankar. Even if I put the value of G as 9.8, let me take out my weapon, the calculator. अरे यार सुधीर, चल ठीक है भाई, सिर्फ और सिर्फ तेरे लिए, ठीक है, okay, चलो, let's do it. हाँ, but definitely I'll need my weapon. I'll need the calculator. अब मेरी एज हो गई है कैलकुलेशंस नहीं करने की. Okay, so 2.475 into G plus V capital V square by 2 is equal to V square by 2. So 2 into 2.475 into कहीं बोला है कि 9.8 लेना है? ओके, पर फिर भी कुछ लोगों ने 10 लिया है, 9.8 लिया. चलो, कुछ लोग डिलिबरेटली अपनी लाइफ को डिफिकल्ट बनाते हैं, कोई बात नहीं. So this becomes capital V square equal to small v square. So small v square and capital V square का गेम है ये. So I'm going to put this value as v by 10. ठीक है everyone? So please multiply this and tell me the value. Meanwhile, I will simplify the rest of the part. So this becomes v square minus v square by 100. So 99 by 100 v square. Okay, good enough. So v square का value is going to be 100 by 99 into 2 into 2.4. This is 48.51. बस तो इसको सिंप्लीफाई कर दो. अब तुमको बताओ आंसर 48 आ सकता है क्या? You only tell me people. Can the answer be 48 now? It is definitely more than 48. Okay, even with 9.8 value, it's not going to be 48. It is more than that. Okay. Okay. Okay, don't worry. In JEE examination, they'll not give you these close options. They don't give you these close options. They will either give you 48 or they'll give you 50. Okay. So no need to argue on that part. For this one, the easier approach was actually to go by this. Okay. Are we clear? Everyone is happy with it? Let's go to the next one. Everybody. Yeah. The top of water tank is open to air and its water level is maintained. Exactly like that question. This is also JEE Main 2019 question. So everybody, the top of water tank is open to air and its water level is maintained. It is giving out 0.74 meter cube of water per minute. Okay, per minute through a circular opening of 2 centimeters, the radius in the wall. So the depth of the center of the opening from the level of water is going to be how much? The water level is maintained. So you want to maintain the water level. Simply, the water coming in per unit time should be equal to water going out per unit time is what you have to solve. Let's see if you people remember how we solved the previous time. You can use the value of pi square as 10. That's one hint given to you here. Okay, and let me also cross verify in the beginning only whether we use G value as 9.8 or not. Okay. G value is to be taken as 10 meters per second square. No arguments on this time. And the time starts in 3, 2, and 1. Forty seconds remaining, everyone. Last 10 seconds approaching. Okay. None of us. Okay, some of us. We got this right. Okay, let's see. So once again, the entire thing was V in is going to be, or V in per unit time is going to be A into V. So this value was given to us as 0.74 per minute. So we can say 0.74 by 60 meter cube per second. Okay. So area of that hole will become pi into 2 into 10 to the power minus 2 ka square into the velocity, that is under root of 2gh. So if you square this value and then simplify this, the value of h can be found. So the time was given to actually do the calculation. So 0.74 by 60 pi r square v, so pi into r ka square into under root of 2gh. When we square this value, we can, or before that we can say under root of 2gh will be equal to 74, and simplifying this divided by 100, this is 10 to the power minus 4. So from here they have brought this 10 to the power 4 over here, so it becomes 74 into 100 divided by 4 into 60, that is 240 multiplied by pi. That's what we get. Okay, so this value actually comes and multiplies with this. So under root of 2gh becomes, after cancelling these, 740 by 24 pi. Squaring this value will be 2gh, 740, 24 into pi square, that is 10. So g value is 10, this is 0, this is 0, this is 0, getting cancelled. So 74, 24. That means 2h can be written to be 74 into 74 by, or other h can be 74 into 74 upon 2 into 24 by 24. So you can see that close to this value is going to cancel it out 3 times. This is also going to cancel it 3 times. 9 by 2. A value little more than that, or nearly by that value. Let's see the options. Okay, but this time the options are not very spaced closed. Okay, they're not spaced very close. So you can see that this is 9 by 2, 4.5 is what I'm getting, right? So I should have gone by that calculation. That's why the answer comes out to be 4.8. Okay, I know the only problem is with Bernoulli's theorem. Okay, it actually is going to be a linear calculation. Looks like 24 slides left. How do we know that? Okay, so everyone, so far we have seen the velocity of E flux. Okay, anyway, so everybody, moving on to speak about something called as Venturi meter. So Venturi meter again was devised by an Italian scientist. Once again, he was Giovanni Battista Venturi. क्या बढ़िया नाम होते हैं ना ये लोग, such beautiful names these guys are. So what matters is basically the surname. So surname was Venturi, and after his surname, out of respect, the device is given the name called as Venturi meter. Now what exactly Venturi meter does? So you know that there are like so many pipelines or in general fluid flowing through multiple pipes. If you want to find out that how fast the fluid is flowing in a given pipe, we install a small device in between. When we say small comparative to the pipe, the device is very small, and this is how it actually looks like. Okay, so you can say that this bigger area of cross section, which is A, is basically the area of actual pipe, and the velocity over here, say it is capital V or V1. So that is the velocity which we are interested in finding, that how fast the fluid is traveling in a given tube. So you can see that in the Venturi meter device, it is devised in such a way, it is designed in such a way that there comes a portion where area of cross section is reduced. Okay, so area of cross section is smaller, and obviously the velocity will change. That velocity is say V2. Okay, and what is noticed here, that you have a U-tube manometer connected over there, so there exists a pressure difference also. Obviously, because of the area difference, because of the velocity difference, pressure difference is also encountered, because usually both the entire Venturi meter cross sections are kept at the same level. Okay, so you can say that this is basically the difference of the height in the two containers. So if we say that here the pressure is P1 and here the pressure is P2, so definitely P1 is greater than P2 here. Can we say that by looking at the U-tube manometer? This is mercury. Can I see that P1 is greater than P2? That is why mercury is pushed more on the left side. Okay, everyone? Yeah. Okay, absolutely. Okay. Okay, everyone. So switching off the chart before you guys start imagining YOUTUBE. Okay. Anyways, guys, so what is our objective? Our objective is to find out the velocity of the flow of the liquid in the actual container. We want to find that out actually. Okay. So see how we are going to do. We are going to apply Bernoulli's theorem between point 1 and point 2. They have different area of cross section, different velocities. They have the same height. This horizontal level is same, and they have different velocity and different pressures also. So see how it will be applied. The final expression is going to be very, very, very weird. It's going to be one of the ugliest looking expressions. So definitely I would not recommend memorizing it. Whenever the question comes, we'll actually apply Bernoulli's theorem. It will be much more easier. So everybody, between point 1 and 2, the area of the actual tube is A. The velocity in the stream which I'm interested in finding is V1. The smaller part of this Venturi meter installation has area small a, velocity is V2. Obviously V2 is going to be more than V1, but my objective is not to find out V2, my objective is to find out V1. So I can write V2 in terms of V1 as capital A by small a into V1. Okay. Now between 1 and 2, I'm going to apply the Bernoulli's theorem. Both have the same height, the horizontal level. Okay. So this height is going to be the same. So you can say that rho GS wala factor is going to be same. So here the pressure is P1, half rho V1 square plus P2 plus half rho V2 square. Actually from here, I should actually be not getting into the derivation from here, because from here the life is going to be simpler if we have been given numerical values. What I'm going to do, guys, we are going to put the value of V2 over here, so that the only unknown left will be V1. So you can see that P1 plus half rho V1 square plus P2 plus half rho A by V V1 square. The V1 is the only unknown now. And usually the pressure difference P1 minus P2 is going to be the pressure difference in the manometer, and that is H rho G. We know this from the understanding from our earlier discussion of fluid statics. Okay, everyone. So I'm going to do one thing. I'm going to bring this P1 here. I'm going to take this half rho V1 square on the right hand side. So pay attention. So P1 plus half rho V1 square plus P2 plus half rho A by V V1 the whole square. So this P2 brought here and this fellow taken there. P1 minus P2 equal to half rho A by capital A square V1 square minus half rho V1 square. So half rho and V1 square will be taken out. This P1 minus P2 is the pressure reading which you are going to get from the manometer, and that is practically you'll be able to measure the difference of height. You can calculate the pressure difference by simply density of mercury multiplied by height multiplied by the G value, and half rho V1 square. You already know the value of the area of the actual tube and the area of the Venturi meter tube. So capital A is known, small a is known, and this value we can calculate numerically. We have been used. So far things are fine. From here they are just calculating V1 expression, finding V1 expression, and that's it. All you are doing is 2 rho. This 2 comes here. 2 rho. Rho mgh by rho. Rho m is the density of mercury in the manometer. Rho is the density of the fluid which is traveling, and this is A by capital A the square minus 1 power 1 by root 2, or I can write it like this also: 2 rho m gh by rho, okay, divided by A by A. Or let's do one thing. This is how it may look a little less scary. This is how it is actually. Okay, or I can also write it as 2 times P1 minus P2 upon rho A by small a ka square minus 1. This whole thing under root. So whichever expression. Expression you want to take a dare to memorize, do it. I do not recommend memorizing it. I recommend understanding the steps. We first wrote V2 in terms of V1, okay, and then we applied Bernoulli's equation. That's it. Equation of motion and the Bernoulli's equation. Okay. Okay. Clear, everyone? So everyone, this is done. So there was supposed to be a quiz question based upon this, but I have removed it from being a quiz. Yeah. So question: the flow of blood in a large artery of an anesthetist dog is diverted through a Venturi meter. Okay, so the wider part of the meter has the area of cross section, that is 8 millimeter square, and the narrow part of that Venturi meter is 4 millimeter square. The pressure drop in the artery is 24 Pascal. Okay, so we have been given the P1 minus P2 value. So what is the speed of the blood in the artery is what we are asking basically, whether the heart is pumping the blood properly or not. So blood pressure is being measured, and how fast the blood is flowing through the veins is what we want to calculate from here. So if we look at it in a much more non-biology way, this is how this situation is. P1 plus half rho V1 square plus P2 plus half rho V2 square. P1 minus P2 is given to us. Also, capital A into V1 and small a into V2. So we are not interested in V2, we are interested in V1. So V2 will be equal to A V1 by small a. Simple. The two equations which I said will matter to us. So we are only going to put this V2 here. We are going to take this P2 here. P1 minus P2 ka value is 24 Pascal. Okay, everyone. So P1 minus P2 becomes half rho V1 square minus half rho V2 square. This is V2 square by the way. But V2 is capital A by small a into V1. That's why it looks like A square by small a square into V1 square. As simple as that. Okay. So we have taken half rho V1 square common. The rest everything else is known to us. P1 minus P2 is 24, and the density of the blood is given, not given. Okay, I have any question because density of the blood is not given in the question. So it should have been given the density of the blood. It is 1.06 into 10 to the power minus 3, and capital A by small a we can easily find out that is 2. So that is 4 minus 1, that is going to be 3. Okay, everyone. So 2 into 24, the pressure difference, density of the blood. I think it's going to be plus 3 here. It's going to be plus 3. Hmm. 1.125 kg per meter cube. Perfect. Okay. Okay, everyone. So eventually what matters is 2, pressure difference, density, and A by A square minus 1. This is coming out to be 3. So 3 will cancel it 8 times. Further, it is 16 by 1.06 into 10 to the power 3 will go up, so that it eventually turns out to be a millisecond or meter per second value. The velocity. Okay, everyone. Wait a minute, yeah. I'm not convinced. This is 3 cancelling it 8 times. 16 by 1.06. Okay, let me use my weapon. 16 divided by 1.06 comes out to be 15, almost 15. So under root is 3.88. But we'll not be able to use that. Okay, so squaring that 15, if 15 is multiplied with 1000, let's multiply it by 10, root 150, so that will be 100 left. So under root of that is 12.25. Okay, just a second, people. 16 divided by 1.06 divided by 10. Under root of this is 1.22. 10 to the power 3, correct. 0.122. So this is what we are getting. We get the value, this one, as something close to 15.09 divided by 1000. Okay, so when you write it as 1.509 divided by 100, the value comes out to be 1.22 by 10. So this is 0.12 meters per second. That's the value that we get. So confirm that density is 10 to the power 3 order, not 10 to the power minus 3, because 10 to the power minus 3 will make it like a very, very light liquid. Okay, but blood is not very light; it is quite a heavy liquid. Okay, so that is why the answer comes out to be 0.125. Again, repeating, all matters in the situation where venturi meter is mentioned in the question is not to actually think of the formula, but think of these 2 points. You don't want to find out the velocity in the venturi tube. You actually want to find out the velocity in the actual tube where the liquid is flowing in the absence of venturi meter also. And after that, you need to just apply Bernoulli's equation between 2 points which are at the same horizontal level. So very simple, the equation is going to be found at. Okay. Good. So after the class, do go through this part by doing the calculations yourself once. Okay, everyone. So let's move on to speak about the other applications of Bernoulli's theorem. So far, we have seen one of the applications as the venturi meter. We have spoken a lot about it in detail, and the other applications are basically the spray bottles, deodorant bottles, how they work, and the lift of an aeroplane is based upon the Bernoulli's equation. So how this works actually? So when you push this part with a very high speed, you obviously try to do this very fast. You try to actually push the bottle's trigger very fast. So when you do that, guys, you basically try to make sure that your air is going to enter at a very high speed, or you basically try to bring the liquid out at a very high speed here. So when the air is going to move very fast, say with a velocity v1, comparative to that, the liquid's velocity over here, v2, is going to be very slow. The liquid is not moving as fast as the air is moving. So we can say that v1 is greater than v2. And wherever this velocity difference happens, just have a look at this equation once, everyone. I want you to have a look at this equation, everybody. So if v1 is greater than v2, can I say that p1 has to be less than p2? Wherever the velocity will be more, the pressure has to be less in the situation where the height difference is not much. When the height difference is not much, practically there is HOG also coming into picture. Okay, so pay attention to this. So when this happens, we can say that P1 is less than P2. That means the liquid becomes the portion which is at a higher pressure comparative to P1. So whenever there is a pressure difference, the liquid will be pushed upward because of a force which is equal to P2 minus P1 into A. A is the area of cross section of this tube. So when we do this, we basically try to make sure that the air comes out or moves at a very high speed so that it creates a lower pressure region. Wherever the velocity of the fluid is going to be very high, almost at the same level, at another point where the velocity is going to be less, wherever the velocity is high, the pressure will be low, wherever the velocity is less, the pressure will be higher. Okay, so this is one of the practical applications. I'll speak very much in detail about the aerodynamic lift in some time. It has a lot to do with the wings. You must have traveled by the flights. When they take off, they basically make sure that the wings get extended a bit. And in that case, they try to basically increase the area of that wingspan so that it gets that lift also. Another reason is there which I will explain in some time. But before that, I want your attention on the typical Bollywood village movie. Okay, have you guys ever noticed that in the typical earlier Bollywood movies, nowadays they don't make movies which are based on villages? I don't know why. I don't even care. But in earlier movies, what used to happen, or maybe during a lot of when the hurricanes come, cyclones come, in the nearby regions, the coastal regions, usually the people don't have like very solid roof. They usually keep the roof made up of tin sheets or say the steel sheets or maybe the cement sheets. So when the wind flows very fast, this rooftop actually goes off, right? You must have definitely seen it in movies or maybe in not more than movies, must have seen it in news also. So there's purely science behind it, purely physics behind it, everybody. Yes, so have a look at this guys, pay attention to this. So what happens when there is wind which is blowing at a very high speed, obviously above the top of this, the house or the hut, okay? And the air inside the house is definitely not moving as fast because of the walls of the house. The air is not moving very fast inside the house. So because of which what happens, these points, point number 1 and point number 2, their height is almost the same. Okay, so when I try to write P1 plus half rho V1 square is equal to P2 plus half rho V2 square, because of this, what happens, as V1 is greater than V2, P1 becomes less than P2. Because of which what happens, the inner portion of the house becomes a high pressure zone. So this becomes a high pressure zone and this becomes a low pressure zone. Okay, because of that, what do you think will be the direction of the effective force which is applied on this rooftop? That is going to be upward. That is P2 minus P1 into A. So the force which is acting upward is going to be P2 minus P1 into A. Is it making sense to all of you? Because of that, the rooftop goes off. It is only going to happen when there is a strong, cyclone kind of wind flowing out of your house and the rooftops are very weak. Okay, when the rooftops are very weak, then this happens. Okay. Yes, I know, Karthik. A lot happens in places like Rajasthan. Okay. Then why the roofs are not strong? Because the chances of the entire house falling are very high, and if the entire house roof will fall down, it's going to cause much more damage comparative to the roof going off. Okay, that's why they deliberately do not create RCC or concrete kind of ceilings. Okay, everyone. Now let's speak about the last part of it, and that is the aerodynamic lift. So yes, pay attention, everyone. So everybody, there is again Bernoulli's science involved in lifting an aeroplane. Have you guys noticed that when the aeroplane has to take off, it moves like at a super fast speed on the runway? Like nothing moves as fast as that aeroplane, right? Exactly. So everyone, this has actually to do with the Bernoulli's principle, and there is a specific type of design. There's a specific type of design of your aeroplane wings. So what happens when the aeroplane is trying to move to the left hand side? Okay, so when the aeroplane is moving to the left hand side, the air will definitely try to cross it. Okay, the design of the wings, the designs of the wings are so beautiful. They are called aerodynamic designs, that they make sure that the air above the wings move with a high velocity and air below the wing moves with a low velocity. The designs are so beautifully made that they create a high velocity zone above the wing, and low velocity zone below the wing. And we know that if velocity is going to be high, then it's going to obviously create a low pressure zone above the wing and high pressure zone below the wing. And as soon as this happens, we can expect a force which is going to create the thrust, which is going to lift the plane. Okay, so again explaining it here. So here we can say that the point 2 and point 1 are almost at the same height. If they're almost at the same height, then we can write the P1 plus half rho V1 square to be almost equal to P2 plus half rho V2 square. And if V1 is greater than V2, V1 is less than V2, then definitely P1 is greater than P2. And overall, the entire aeroplane experiences a force upward. Okay, everyone? More or less the similar explanation as we saw for the rooftop of the house going off. Okay, everyone? Yes. So if we look at the streamlines of air around the wings of an aeroplane, this is the kind of situation. So when the lift is to be taken, the design becomes like this. This is the explanation, Sumit Srivastava. The design of the wings, the design of the aeroplane wing is such that it makes the air flow faster at the top and doesn't let the air move very fast below it. Okay, Sumit Srivastava, is it clear? Sumit Srivastava, are we there? Not exactly. A parachute का concept अलग है. ठीक है, everyone? Yeah. Good. So chalo, let's solve some question, and then there will be question of the day for all of you guys. Yeah. So we'll speak after that, all of you. Question in front of you. The total area of the wings of the aeroplane is 10 meter per second square. 10 meters square. The speed of the air above and below the wings is 140 and 110 meters per second. Then the force on the aeroplane by the air will be how much? So force which is going to be P2 minus P1 into A. How much is this going to be? You have to find out the value of P2 minus P1. All I can say is P plus half rho V square is going to be constant. So apply this between 1 and 2 and try to solve this. Giving you people 2 minutes, complete 2 minutes, and the time starts in 3, 2, and 1. Jaldi solve bhi kar liya. Shabash. Half time gone. Last 15 seconds, everybody. Okay, time's up. Let's see. So concept was simple, but the application required calculations. So half rho V1 square is going to be P2 plus half rho V2 square. So P2 minus P1 is I need. So P2 minus P1 is going to be half rho V1 square minus V2 square. So Is the density of air missing here? Do we know the density of air from chemistry? 1.2 or 1.3 kg per meter cube. Mole concept नहीं सिखा तुम लोगों को? You people are lying. You people are lying there. The density of air is taught in chemistry. It's 1.28 kg per meter cube. Yes, I confirmed it with Captain already. Yes. Doesn't matter how much you say no. Yes, it is taught in chemistry. Any which way. So, ठीक है चलो कोई बात नहीं. No problem. Any which way, guys. So half into density into V1 square minus V2 square. That's going to be the value of the pressure, and this will, after solving, come out to be 4,800. So multiply that value by the area, that is 10. So 48,000 Newton. Obviously, a huge force is required for the lift. Captain didn't teach gaseous state. Kyun bhai? What were you doing in mole concept? Okay. Don't worry, this was not a JEE question. In JEE examination, they'll give you the density of air. If this was a question there. Okay. Anyway, chalo guys, before we will call it the day, there is a question of the day. Question of the day for all of you. So we have this question from the first part of the day today, and that was velocity of efflux. Pay attention, this is JEE 2016 question. We have some liquid which is filled on the top of this part of the container whose radius is capital R. Then there, you know what happens? The water starts to leak out in the form of a stream. So the hole has a radius of small r, and when the stream is falling by a height x, the radius of that stream becomes x. Okay. So question is asking us, when the stream has fallen by a height of h, and the stream is going to have the radius as x, then what do you think is the relation between x and r? What is the relation between this radius and this radius? That means the two streams. What is going to be the difference? Here the velocity is going to be say v1. Here the velocity is going to be v2. You can use the velocity of efflux formula for v1 and v2 both, and then see if you can correlate it. I'm giving you guys 4 minutes for this question. Okay, and your first 2 minutes start in 3, 2, and 1. So after 2 minutes, I'll be starting the timer. Okay. Okay, and 1 minute is gone. After 1 more minute, I'll be starting the timer of 2 minutes. Okay, and 3, 2, and here we go. More time should be given to think about this question rather than trying to rush through solving it. Okay, everybody. .40 minutes, 40 seconds more. Okay, last 15 seconds now, everybody. Come on, come on, come on, come on, come on. And the time is up. Moment of truth. Let's see. Okay, majority people went with option C. I don't know why. But must have been some reason. So, yeah, everyone. If we speak about the velocity v1, the height of the liquid above it is capital H. So you can say that the velocity of efflux is going to be under root of 2gh. I told you people you can use the formulas. Similarly, v2, the height of the liquid above it is h plus h. So 2gh plus h. Okay, here the area is A1, here the area is A2. So I can say that A1 V1 will be equal to A2 V2. A1 is going to be pi r square, V1 is under root of 2gh. A2 is pi x square, and this is 2gh plus h in under root. Pi got cancelled, and we can say that x square by r square is going to be 2gh by 2gh plus h, and this is in under root. That means power is half. So 2g gets cancelled, and we can say that x square by r square is equal to h upon h plus h power half. So x by r will be equal to h upon h plus h power 1 by 4. So x will be equal to r times h upon h plus h power 1 by 4. That's why the right answer. I know. Wrong tagging. यार चीटिंग मैंने तो नहीं की. मैंने तो तुम्हारे सामने वही सॉल्व किया है जो आंसर होना चाहिए. Let's thumbs down this question, guys. Let's do the thumbs down. Okay. Answer is option C. Please, everybody give the feedback. Okay, यहाँ पे भी correction होगा. ठीक है. How many of you got the answer? This one. How many of you got this answer? They deserve a round of applause for that, by the way, because this was a good question to crack. Yes, absolutely. Here we go. For all those students who got this question right, irrespective whether it was wrongly tagged or correctly tagged, it's not that. What matters is that we could solve this question. JEE 2016. Okay. Okay. अरे यार यहाँ पे होल है तो यहाँ से लिक्विड का लेवल का हाइट h plus h होगा ना रियांशु h plus h and if the hole is here the height is only capital H, that is why. Okay, I know, absolutely. So this is the leaderboard for today, though the leaderboard is not absolutely correct today, but any which way what matters is the last question. ठीक है, and the hole. Okay, good job everyone, good job, especially those who got this last question right. Okay, yes, absolutely. Okay, why 2x as in where we have done 2x? What is 2x? कहाँ है 2x? कौन सा डायग्राम? वो डायमीटर है. 2r and 2x are telling you the diameter. I hope that you guys can guess that part by looking at the diagram also, that it's the diameter that they're telling us 2r and 2x. Okay, okay, ये लो. ये तो क्वेश्चन स्टार्ट होने से पहले देना चाहिए था मुझे ड्रम रोल, है ना? रोल तो हो चुका ऑब्वियसली, ऑलरेडी हो गया. Okay, will diagram be given in G? Depends. Sometimes they give, sometimes they don't. In this question, definitely the diagram was there. Okay. Yes, everyone. So officially the class slides are done. Class teachers, if you're done explaining your doubts, you can leave the class, and other students can as well. Okay. Bye bye, Adesh. Bye bye, Aditya. Bye bye, Ishika. Okay. Bye bye, bye bye, bye bye, bye bye, bye bye. Hey, Vihan Gargava, you are here. Hi, Vihan. How are you? बस यार, as usual. अच्छा, okay, ठीक है. Tell me. Question. सुनाई नहीं दे रहा क्लियरली. क्वेश्चन हाँ अभी बेटर है, बोलो. अच्छा, आई नॉट ई टू द पावर. अच्छा, टी बाय आरसी. ओके, तो आरसी का डायमेंशन पूछे हैं. आरसी का डायमेंशन वही होंगे जो टाइम के हैं, क्योंकि साइन का थीटा, कॉस का थीटा, टैन का थीटा, लॉग का आर्गुमेंट और ई की पावर हमेशा डायमेंशन लेस होते हैं. आरसी के डायमेंशन साइन के डायमेंशन है. अरे डायमेंशन आरसी के डायमेंशन है टी टू द पावर 1 एम 0 0 टी 1. हाँ बिल्कुल. तो वो सेम है, यही वाला लास्ट जो थर्ड एप्लीकेशन होता है ना, जस्ट पोटेंशियल एनर्जी डिपेंडिंग ऑन मास टू द पावर ए जी टू द पावर बी एच टू द पावर सी. तो जिसमें फंडामेंटल क्वांटिटी बोल दें कि मान लो लेट्स से फोर्स एज, जैसे मान लो फोर्स को और फोर्स को, उसके अलावा टाइम को, और मान लो मास को फंडामेंटल क्वांटिटी ले लिया और पूछ रहे हैं कि मोमेंटम के डायमेंशंस क्या होंगे. ठीक है, तो सिंपली बोलोगे कि मोमेंटम इज गोइंग टू बी प्रोपोर्शनल टू एफ टू द पावर ए टी टू द पावर बी एम टू द पावर सी, और सिंपलीफाई करेंगे बस, फॉर्मूला बन जाएगा. अच्छा, थर्ड एप्लीकेशन ऑफ डायमेंशंस एनालिसिस किया है ना, बस वही अप्लाई करना है और कुछ नहीं. चलो दैट्स नाइस, वेरी गुड, वेरी गुड, वेरी गुड. कैरी ऑन. ठीक है. गुड गुड, अच्छा है. चलो इट इज हेल्पिंग यू आउट, दैट्स नाइस. ओके ओके भैया, बाय बाय, टेक केयर, गुड नाइट. Speed of water through the hole depend on the point at the bottommost. Harshan, it depends on this level. So if it is here, anywhere here, it's going to have this. It's what's matter is the height above the hole. The velocity of E plus depends upon the height above the hole. ठीक है? Yes, अंशु. कौन सा वाला? ढूंढना पड़ेगा, स्लाइड नंबर भी नहीं याद है. ये वाला. इसमें क्या बोला कि जितना पानी हर सेकंड तुम यहाँ पे भर रहे हो, उतना ही पानी यहाँ से बाहर भी आना चाहिए. ठीक है, तो हमने क्या लिखा कि अगर 10 टू द पावर -4 मीटर क्यूब पर सेकंड इतना वॉल्यूम पर यूनिट टाइम कंटेनर में भर रहे हैं, तो वो हो गया वॉल्यूम पर यूनिट टाइम कमिंग इन, उतना ही कमिंग आउट होना चाहिए. तो अब इस होल से अगर वाटर बाहर आ रहा है तो उसका एरिया कैपिटल ले लिया और वहां से आने वाले वाटर की वेलोसिटी यू ले ली. ठीक है, तो ये वेलोसिटी हम कैसे निकालेंगे, क्योंकि वेलोसिटी स्मॉल होल से आने वाले वाटर के लिए है, तो मैं उसे बोल सकता हूँ कि वो वेलोसिटी ऑफ ई फ्लक्स है. ठीक है, तो उसे लिख दिया √2gh. ये जो होल है उसका एरिया हमें दिया हुआ है 1 सेंटीमीटर स्क्वायर, तो सेंटीमीटर स्क्वायर को मीटर स्क्वायर में कन्वर्ट करूंगा तो 10 टू द पावर -4 बन जाएगा. ठीक है, और ऑलरेडी वाटर जब आ रहा था अंदर तो उसी रेट से बाहर आ रहा है, वैसे 10 टू द पावर -4 दोनों कैंसिल हो गए. तो h का वैल्यू आ गया 1/20 मीटर, 5 सेंटीमीटर. ठीक है, समझ गए? ओके. ये सुनिए, थोड़ा बहुत, थोड़ा बहुत। क्या? तुम कितना धीरे बोल रहे हो? हाँ बोलो बोलो। हाँ वेंचुरी मीटर से बोलो ना। हाइट तो सेम है, नैनोमीटर तो हम ऑलरेडी पढ़ चुके हैं, क्योंकि यहाँ पे वेलोसिटी चेंज हो गई है। तो वेलोसिटी चेंज ही इसलिए हुई क्योंकि प्रेशर का डिफरेंस क्रिएट किया। और ये बात हम इक्वेशन ऑफ कंटिन्यूटी में देख चुके हैं कि अगर मान लो पाइप से वाटर बाहर आ रहा है और मैं अगर पाइप के आगे का पोर्शन थोड़ा सा आधा सा बंद कर देता हूँ, तो अब वाटर और फास्ट आने लग जाता है। कभी पाइप जिससे हम पानी ऐसे भरते हैं या कहीं पे पेड़ों में पानी डालते हैं, कभी कोशिश करना उस पूरे पाइप को कंप्लीटली बंद करने की, बहुत स्ट्रॉन्ग प्रेशर क्रिएट हो जाता है हमारे अंगूठे के ऊपर। तो डेफिनेटली प्रेशर में डिफरेंस आता है अगर हम वेलोसिटी को चेंज करने की कोशिश करते हैं, एरिया को चेंज करने की कोशिश करते हैं, और वही यहाँ पे हो रहा है। गेटिंग? तो वो प्रेशर डिफरेंस आ ही एरिया के शेप चेंज होने की वजह से और वेलोसिटी के चेंज होने की वजह से रहा। हाँ नैरो स्विंग में बदल जाता है। हाँ वो भी कल एक्सप्लेन किया था, कल की क्लास में नहीं आए थे, अभी मंडे की क्लास में। हाँ थे, ये क्वेश्चन सॉल्व कर पाए थे तुम ये वाला आज? हाँ अरे कोई से भी मेथड से, लॉन्ग मेथड से करो, स्मॉल मेथड से करो, एक्सप्लेनेशन वहीं पे दिया था कि यहाँ पे जैसे जैसे लिक्विड नीचे गिरता जाएगा उसका वेलोसिटी बढ़ता चला जाएगा। तो अगर वेलोसिटी बढ़ेगा तो एरिया को कम होना ही पड़ेगा, इसलिए एरिया स्ट्रिंग का छोटा होता चला जाता है और नैरो होती चली जाती है स्ट्रिंग बाय इक्वेशन ऑफ कंटिन्यूटी। और बोलो, दैट्स इट, ठीक है चलो ओके टेक केयर। अरे तुम लोग क्या डिस्कशन कर रहे हो? टॉक टू योर सैम, डू नॉट डिस्कस इट हियर, ओके? जिसको जो भी बैच रिलेटेड सवाल हैं, स्पीक टू योर स्टूडेंट एकेडमिक मैनेजर। अंश गेट अ माइक्रोफोन, या तो अनम्यूट होने के लिए माइक्रोफोन एक्सेस दे दो पहले। अंश कोरियान। हाँ भाई बाकी जनता के लिए आस्था लाभिस्ता, कैसे तो मुझे नहीं पता भाई, जिस भी ब्राउजर को यूज कर रहे हो उस ब्राउजर में एक्सेस देने वाली चीजें आज की जनरेशन से मैं एक्सपेक्ट करता हूँ। वेंचुरी मीटर की स्लाइड ये रही, आई थिंक तुम ये देखना चाहते हो। एक काम करो ना अंश, जो भी ब्राउजर यूज कर रहे हो उसकी जगह दूसरा ब्राउजर से लॉगिन करके आ जाओ। तो जब लॉगिन करके अंदर आओगे सेशन में तब वो एक्सेस मांगता है कि माइक्रोफोन और कैमरा को एक्सेस देनी है क्या, ठीक है? बस वहां से दे देना यार। क्यों हट जाएगी? अभी 10 नहीं बजे, 10 बजे के बाद हटती है, अभी 10 बजे नहीं है। सर आप एज अ स्टूडेंट अर्ली राइजर थे क्या? मैं कभी भी अर्ली राइजर नहीं था, लेकिन यही प्रिपरेशन में मैं अर्ली राइजर बन गया था। मे बी शायद उस टाइम पे बोलते ना दैट वाज द नीड ऑफ द आवर, दैट्स व्हाई आई एम नॉट एन अर्ली राइजर। मैं कितने बजे उठता था? मैं आई थिंक 6:30 7 बजे उठता था। सर इंटिंगो डाइक, इंटिंगो क्या है? इंटिंगो क्या होता है? कोई ब्राउजर है? अब तो मैं बिल्कुल भी अर्ली राइजर नहीं हूँ, मैं 9-10 बजे सो के उठता हूँ। हाँ भाई इनकॉग्निटो ट्राई कर लो, कोई सा भी मोड ट्राई कर ले, पर ब्राउजर नया चेंज कर ले मेरे भाई। सर डू यू वांट डार्क मोड वेदांतु? आई डोंट लाइक डार्क मोड ऑफ एनीथिंग। सर बट यू वर्क टिल नाइट ना? हाँ एग्जैक्टली दैट इज व्हाई, बट आई एम एनी व्हिच वे नॉट एन अर्ली राइजर। सर बड़े कैलकुलेशन कैसे मास्टर कर सकते हैं? बाय राउंडिंग ऑफ द वैल्यूज बिफोर कैलकुलेटिंग। कैलकुलेशन से पहले ऑप्शन पे नजर डाल लो, अगर ऑप्शंस अच्छे खासे दूर हैं तो कैलकुलेशन से पहले राउंड ऑफ कर लो। वो जैसे 74/24 74/24 आया था, मैं मान लूंगा 75/25 है वो। Sir, why the raindrop do not penetrate us while falling from a great height? Sadiq Irfan will answer this question when we study viscosity in the next class. I'll give you the answer of this, that why raindrops do not hit us very hard, they do not kill us. So I'll give you the reason of that. So do you watch anime or play games? I don't do both. I spend very less time on screen. I do not watch any series. I do not play games at all on mobile phone. So concept समझ आते हैं कि क्वेश्चन सॉल्व करने में इशू होता है. That simply is an indicator कि concept clear नहीं है. So then what do you do for entertainment? I wait for cricket matches to happen. Or I watch maybe some dance reality shows. I'm like a regular follower of IPL every cricket match. हाँ डांस प्लस यू नेम इट, आई सीन एवरी डांस शो। सर आपने सीएसके केकेआर देखा था? अरे सीएसके केकेआर वाले दिन आई वाज इन बैंगलोर एंड दैट वाज द रिजल्ट डे। अरे एब्सोल्युटली गोज विदाउट सेइंग, इंडिया पाकिस्तान का कोई मैच छोड़ते हैं अपन? बिल्कुल नहीं। नहीं आई एम नॉट गोइंग, मोस्टली अनुष्का आई एम नॉट गोइंग। हाँ अभियान बहुत ही अमेजिंग रिजल्ट आया यार। स्टिल सेशन लाइव। सर डिड यू सी टुडेस मैच? सर हाँ आज इंडिया और ऑस्ट्रेलिया मैच चल रहा था, आई वाज फॉलोइंग इट। हाँ भाई दुनिया को पता है 24 अक्टूबर इंडिया पाकिस्तान। सर लाइफ एट आईआईटी बॉम्बे वाली रिलीज होगी कब वीडियो? लाइफ एट आईआईटी बॉम्बे की कौन सी वीडियो है? सर आई डोंट फॉलो क्रिकेट, इज इट अ क्राइम? अरे एब्सोल्युटली यार, आई नो दैट एड वेरी वेल, आई हैव बीन वाचिंग दैट एड फॉर इयर्स नाउ। टीवी सप्लाईज रोज इन पाकिस्तान ऑब्वियसली। तो स्कूल में फिजिक्स में 45 में से 44 आए, दिल टूट गया। शो ऑफ है ये मानव जोशी का शो ऑफ है। तो आई थिंक मैंने लाइफ एट आईआईटी, लाइफ माय ड्रॉप ईयर स्टोरी वहां जरूर बात की है उस बारे में। लाइफ एट आईआईटी के बारे में वीडियो करना है, हाँ याद आ गया। ठीक है करते हैं कभी तो यार। अरे अंश गोरियान आया नहीं अभी तक। अंश आर यू हियर? ओके गौतम दैट्स गुड। सर जी आपकी आवाज़ इन वाईटी सेशन एंड वेव में अलग हो जाती है, मतलब सर अलग अलग लगता है। कहाँ ज़्यादा बेटर आती है विहान? आवाज यूट्यूब पे बेटर आती है या वेव? आई थिंक वेव में ज्यादा बेटर आती है ना आवाज। हाँ आई नो आई नो। उसके दो रीजन है, एक तो ये जो उसका माइक्रोफोन है ना वो बहुत ज्यादा सेंसिटिव है, तो वो जो एसी ऊपर चल रहा है और बिना एसी के मैं सेशन नहीं ले सकता, क्योंकि उसमें मैं सीलिंग फैन नहीं चला सकता, तो उसमें मुझे एसी चलाना पड़ता है और एसी की आवाज आती है। तुम्हारे सेशंस में फैन चला सकता हूँ। सर कैन यू पोस्ट एनी वीडियो इन वेदांतु चैनल है? वाईटी सही है सर, वहाँ माइक यूज करते हो ना? अच्छा कुछ लोग बोल रहे हैं यूट्यूब पे ज्यादा अच्छी आवाज आती है। मुझे पर्सनली यूट्यूब वाली साउंड थोड़ी सी इरिटेटिंग लगती है बिकॉज़ ऑफ द बैकग्राउंड नॉइज ऑफ माय एयर कंडीशनर कंप्रेसर, उसके कंप्रेसर की आवाज बहुत ज्यादा आती है। अंश गोरियान आर यू हियर? थैंक यू आदिश। लाइक कैन यू मेक अ वीडियो एंड पोस्ट इट इन सर? I can, but I do not because there is a team working on it, and that's not my personal channel. So obviously, okay, Vihan, that's good. Okay, Ansh. Yes, finally, Ansh, कौन से ब्राउजर पे किया लॉगिन? Which browser you are using? अच्छा ठीक है, अभी बताओ तुम्हें कैविटी का मतलब कौन सा सेंटर ऑफ मास मूवमेंट ऑफ इनर्शिया? व्हाट एग्जैक्टली? नहीं क्वेश्चन नहीं बोलना है, ये बताओ सेंटर ऑफ मास का क्वेश्चन है या मूवमेंट ऑफ इनर्शिया का क्वेश्चन? फ्लूइड्स में कैविटी? अच्छा बोलो सर। उसमें कैविटी का अंदर हीट तो व्हाट? कैविटी कॉन्सेंट्रेट है, ठीक है, तो हॉलो बॉल है, हॉलो बॉल है और क्या? अब तुम्हें ये मालूम है कि मास तो सिर्फ यहीं पे अवेलेबल है, तो रेडियस दिया है क्या अंदर और बाहर का? और क्या बोला है, कितना कंप्लीटली समझ है? हाँ जस्ट ठीक है, तो ये जो रेडियस है मान लो ये स्मॉल आर है, ये वाला रेडियस कैपिटल आर है, तो क्या मैं बोल सकता हूँ जो एक्चुअल वॉल्यूम ऑफ द कंटेनर है जहाँ पे मास है, सॉरी कंटेनर नहीं बॉल जो है, उसका वॉल्यूम मैं लिखूंगा 4/3 पाई कैपिटल आर क्यूब माइनस 4/3 पाई स्मॉल आर क्यूब, है ना? अंदर वाले स्फीयर का वॉल्यूम माइनस कर दूंगा क्योंकि वहाँ मास ही नहीं है। mg लिखने का मतलब हुआ 4/3 पाई आर क्यूब माइनस स्मॉल आर क्यूब इंटू जी, हो गया। इसको इक्वेट कर दूंगा, जब इसको इक्वेट करूंगा बाय एंड फोर्स से, तो बाय एंड फोर्स को इस बात से फर्क नहीं पड़ता कि अंदर अंदर मास है या नहीं है, उसको इस बात से फर्क पड़ता है कितना वॉल्यूम अंदर आया टोटल। तो वो जब लिखा जाएगा ना रो वी जी, तो ये वॉल्यूम पूरा का पूरा मिलेगा, इसको लिखा जाएगा रो इंटू 4/3 पाई कैपिटल आर क्यूब इंटू जी, समझे? और ये दोनों इक्वेट कर देना, इन दोनों को इक्वेट कर देना और फिर सिंप्लीफाई कर देना फॉर आर क्यूब एंड आर क्यूब, स्मॉल आर और बड़े आर के लिए सिंप्लीफाई कर देना इक्वेट करने के बाद में, तो जैसे ही तुम्हें रेशियो मिला आर क्यूब बाय कैपिटल आर क्यूब, यही तो रेशियो होगा 4/3 पाई आर क्यूब और 4/3 पाई आर क्यूब का, बस दैट्स व्हाट यू आर लुकिंग फॉर। अब समझ में आ गई अप्रोच, एक बार और ट्राई करना, ठीक है? ठीक है बढ़िया गया, है ना? हम्म। दैट्स एब्सोल्युटली फाइन। एक बात पे नजर रखना, अगर तुमसे 2006 ऑनवर्ड्स के क्वेश्चन बन जाते हैं, इट्स अ गुड इंडिकेटर। 2006 से पहले वाले सवाल एक्चुअली बहुत अलग लेवल के एडवांस क्वेश्चन है। 2006 से पहले के क्वेश्चन इजी थे। कोई बात नहीं, पर ऐसा नहीं है ना कि बिल्कुल ही नहीं हिलते, कुछ कुछ तो क्वेश्चन हो पाते हैं। तो बेसिकली एप्टीट्यूड डेवलप हो रहा है दोस्त, अच्छा डेवलप हो रहा है, तो अगर कर पा रहे हो और फाइट मार पा रहे हो, दैट इज वेरी इंपॉर्टेंट। वो कर पाना इज रियली अ गुड साइन इन इटसेल्फ। अगर तुम मान लो यार, अगर तुम 50% क्वेश्चन भी एडवांस के सही से कर पा रहे हो ना, दैट्स एक्चुअली अ गुड इंडिकेटर, है ना? क्या बोल रहे हो? 50% राइट, 50%, बस तो अच्छा साइन है दोस्त, यू आर ऑन द राइट ट्रैक, करते चलो। हम्म, तो एक बार बात करो हर्ष सर से, उनको बताओ प्रॉब्लम, वो ज़्यादा अच्छे से डायग्नोस करेंगे एक्जैक्टली कहाँ तकलीफ है। बस एक्चुअली बात वही है, घूम करके बस हैंडल ले रहे हैं आज नहीं तो कल तो उसकी नाक आ जाएगी, है ना? वैसे स्कूल में बढ़िया, लकी भाई, लकी, अच्छी बात है, अच्छी बात है, गुड है, गुड है, अच्छा है। ठीक है, तो यूटिलाइज कर रहे हो ना टाइम को, वो ज़्यादा इंपॉर्टेंट है। बहुत बढ़िया, कहाँ से हो तुम? बिजनौर से हो, ठीक है बढ़िया, अच्छे से इस्तेमाल करो टाइम को। कहाँ यूट्यूब पे? क्या था कमेंट? अच्छा अच्छा अच्छा। यार ये एक्चुअली बड़ा कॉमन सा पॉइंट है ना, तो बहुत बार बहुत लोग पूछ ही लेते हैं, बट अच्छी बात है कि आज तुम्हारी बात हो गई, तो कम से कम तुम्हारा जो डाउट था वो क्लियर हो गया, है ना? तुम्हारा माइक्रोफोन ही नहीं चलता इसलिए। नहीं ब्राउजर से भी होता है दोस्त, बेसिकली वो जो जहाँ पे अपन लिखते हैं ना वेदांतु.com, जहाँ लिखा जाता है उसी वाले पार्ट में सबसे राइट में से एक कैमरे का साइन बना हुआ होगा, उस पर क्लिक करना, वहाँ पे परमिशन मांगता है कि आप चाहते हो कि आपको कोई अनम्यूट कर सके या नहीं कर सके, सिंपल। ब्राउजर दूसरा यूज कर लेना, क्या नाम है इस ब्राउजर का, मैं कौन सा यूज करता हूं, माइक्रोसॉफ्ट एज करके एक ब्राउजर है, वो यूज कर लो। तुम गूगल क्रोम यूज करते होंगे ना? हाँ, तो एक माइक्रोसॉफ्ट एज करके आता है, मैं लिख देता हूँ, तुम उसे डाउनलोड कर लेना। मैं खुद उससे ही लाइव रहता हूँ, मेरा गूगल क्रोम पर चलता ही नहीं है, कैमरा ही नहीं एक्सेस देता। ठीक है, तो ये तुम डाउनलोड करके इससे एक बार ट्राई करना, शायद से तुम्हें मोबाइल पे आने की जरूरत ना पड़े ऐसे कॉन्वर्सेशन करने के। आई नो, अगर मैं सो जाता तो क्लास में इंटरेंगे में। ठीक है, चलो, ओके अंश, टेक केयर, बाय बाय। सर, द वेलोसिटी ऑफ व्हीकल्स ओनली डिपेंड ऑन हाइट, सो दैट व्हाट व्हाई लास्ट पॉइंट हैज। अरे मित्र, जहाँ पे भी तुम वेलोसिटी पता लगाना चाहते हो ना, वहां से लिक्विड कितना ऊपर लेवल तक है, तो एच प्लस एच है, इसलिए इसीलिए बिल्कुल बिल्कुल है ना। ओके सर, डू यू टेक एडवांस क्वेश्चंस इन क्लास स्लाइड्स? तो यार, दीज आर ऑलरेडी मेड स्लाइड्स, यूजुअली इसमें एडवांस लेवल ऑफ क्वेश्चंस आ ही जाते हैं जो हम लोग कर लेते हैं, है ना। ठीक है, तो चपाटी, लेट्स कॉल इट द नाइट, मिलते हैं अगले वीक। यस, ओके एवरीबॉडी, चलो साइन ऑफ किया जाए। गौतम कहता है कि सर, पर जब मैं इंडिविजुअली एडवांस क्वेश्चन सॉल्व करने जाता हूँ तब 10% ही होते हैं, क्या करूँ? 10% को 15 पे लाओ, 15 को 20% पे लाओ, धीरे धीरे। ठीक है, क्वेश्चन से जूझने की कोशिश करो, मतलब स्ट्रगल करने की कोशिश करो, क्वेश्चन से गिव अप मत मारो। कोशिश करो कि क्वेश्चन समझ में आए, कॉन्सेप्ट अप्लाई हो पाए, जो पढ़ रहे हो ना वो वहाँ पे एप्लीकेबल। क्वेश्चन स्टार्ट करूँ तो सॉल्व कर ही लेता हूँ, वही तो चाहिए यार। सर, हमसे तो 10% भी नहीं होते, बहुत बढ़िया, सब मुंह माया वैसे भी ना इसी का। गुड गौतम, तो धीरे 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 इंप्रूव करो, किसी से ज्यादा सवाल बनते हैं, किसी से कम बनते हैं, व्हाट इज इंपॉर्टेंट कि तुम जहां आज हो, आज से 1 महीने बाद थोड़ा सा इंप्रूवमेंट दिखना चाहिए तुम्हें खुद को, दैट इज व्हाट इज इंपॉर्टेंट, है ना। Cool. चलो, good. Sir, you are in a good mood today. When am I not? I'm always in good mood. Last class में I was tired. I told you guys. I was tired. Otherwise, I'm in a good mood always. And that day I was super hungry also. उसकी लास्ट में हर सर के घर में। हाँ, आई नो, थैंक यू आदिश। अभी जज मत करो अपने आप को एडवांस के ऊपर, ठीक है गौतम। ओके, दैट्स गुड आर्यन। समटाइम्स यू आर मोर रिलैक्स, समटाइम्स यू आर नॉट दैट रिलैक्स्ड, डेज आर डिफरेंट, तुम्हारी तरह हमारी लाइफ में भी अप्स एंड डाउन चलते रहते हैं। है ना। चलो गाइस, आई आल्सो हैड फन, फाइनली लेट मी गो एंड सी इफ आई गेट सम डिनर और नॉट। ठीक है, सो आई विल सी यू ऑल नेक्स्ट वीक, खिचड़ी खाते हैं, मिलते हैं नेक्स्ट वीक। टिल देन टेक केयर, बाय बाय, हasta la vista, sayonara, signing off guys, bye bye, bye bye guys, yes, love you all.